today's class is, right, how to find out time complexity. That is a goal. Right, today we are going to discuss how to find out time complexity. Right, so I made all the things ready also. In today's class we are going to cover approximately, I think I can say approximately, right, 8 programs we are going to calculate. 8 programs time complexity we are going to calculate. Right, problems also ready. 8 programs, not 1 or 2, 8 programs we are going to find out time complexity. If you listen properly, today's class, tomorrow's class, day after tomorrow's class, 3 classes are there. 3 classes are there. If you carefully follow, you will get to know how to find out time complexity. Just 3 lectures. Today, tomorrow, day after tomorrow. Today, basic problems we will cover. Tomorrow we'll cover the middle problems. Day after tomorrow we are going to cover difficult problems. Totally we are going to cover, right, approximately 30 programs. How to find out time complexity. Right, and one more thing is, whenever this class going on, if you find out that small doubt also at any way, in the comment section you can comment. In the comment section you can comment. Let's go ahead. How to find out time complexity. So listen everyone. So that story is called as analysis. How to find out time complexity. That story is called as analysis. Time complexity finding, class number 1. Time complexity finding, right, class number 1. Right, whatever process you are doing to find out time complexity, that is known as analysis. Right, I given the definition also, you can see here. In order to solve any problem, if you have more than one solution, then the best solution will be decided or computed by analysis based on 2 factors. Means if a problem having more than one solution, best solution means what? Time complexity finding, space complexity finding. So I have more than one solution, best solution will be computed based on 2 factors, time complexity, space complexity. Analysis purpose is not only finding time complexity, space complexity also. Why are you finding time complexity, space complexity? If a problem having more than one solution, best solution will be identified by, right, these 2 factors. Suppose assume that these 2, time complexity, space complexity, these 2 best, then that is the best algorithm. These 2 are worst, then it is a worst algorithm. Right, I'm repeating once again. The purpose of today's class is finding time complexity. That is the purpose. Right, for that we are starting analysis. What is the analysis? Right, analysis purpose is a problem having more than one solution, which is the best solution. Right, analysis will identify. How it will identify? Based on 2 factors, time complexity, space complexity. Some people are asking, sir, what is time complexity? Can you see here? I will give these notes also. You will get the clarity. Right, see this one. Based on these 2 factors, analysis will decide which is the best algorithm. Right, what are the 2 things? Time complexity how much, space complexity how much. What is the meaning of time complexity? While running, how much time the CPU is taking, that is called time complexity. While running the program, how much time CPU is taking, that is called time complexity. Next one, while running, how much space, how much main memory space you are taking. Your program taking how much main memory space, that is called space complexity. Based on these 2 people, analysis will decide which is the best solution. Right, I think, see, you no need to write also, first listen. You I will give these notes also. You will get the clarity. Today, tomorrow, day after tomorrow, these 3 days for the purpose of finding time complexity. How to find out time complexity? 30 problems I will cover. Today easy problem, tomorrow middle problem, day after tomorrow difficult problem. If you can listen these 3 classes, you will find out time complexity. Next one. So I am going to cover time complexity. First of all, why are you finding time complexity? Right, analysis purpose. Why are you analyzing? To find out best solution. Right, what is the meaning of analysis? If a problem having more than one solution, best solution will be computed. Best solution will be computed by analysis based on 2 factors. What are those two factors? While running, that program taking how much time? That is called time complexity. While running, that program is taking how much space? That is called space complexity. Okay. This also we done. This also we done. But now let's concentrate time complexity. Let's concentrate time complexity. Right? Time complexity of your program. Time complexity of your program is nothing but, first of all, if you want to see output of any program, that is called time complexity of your program. Time complexity of your program is nothing but compilation time, how much required, right? Time for compilation, time for running. When you want to see output of any program, first you have to compile, next you have to run. So how much compile time it is taking? Next one, how much running time it is taking? These two combinedly called as time complexity of your program. But remember, compiler is a software. Compiler is the right. Compiler is a software. Processor, running is nothing but a processor. Compilation is based on the compiler. Running is based on the processor. So from today onwards, if anyone asks you how to find out a time complexity of a program, simply say time complexity of program is nothing but compile time plus running time. Immediate question, compile time. So compile time is based on compiler. Running time is based on processor. Okay, fine. Next one, compiler is a software. Yes. Right. I think the next one, processor is a hardware. Yes. So what I mean to say is time complexity based on compilation purpose, which software you are using. Right. Running purpose, which processor you are using. Suppose assume that compiler is a software. Right. Which software means compiler means software. Software means program. Program means in which language you written. So remember, compilation time is based on a compiler, which is a software. That software written using which language? Suppose assume that software is written right using faster language. Compile time is less. That software is written using slow language. Compile time is more. I'm repeating again. Very simple, very simple. Just the purpose of today's class. The purpose of today's class is very simple. How to find time complexity. Right? In next question immediately. Time complexity of program. How? Time complexity of your program is right. Time complexity, time required for compilation, time required for running. Okay, time required for compilation. It is based on compiler. But compiler is a software. That software is written using which language? Suppose assume software is written using slow language. Compile time is more. That software is written using faster language. Compile time is right less. Next one. Running time is based on the processor, which is the hardware. Right? Suppose assume i5, let us it will take 10 minutes. i7, it may take 8 minutes. i9, it may take 5 minutes. So type of processor matter. Right? M5, M5 maybe, M7 maybe, M9 maybe. So different types of processors are available. So type of hardware matter. So time complexity based on what is the language of compiler, what is the type of hardware, what is the type of CPU. Time complexity based on two things, language of compiler and type of hardware. Now observe everyone. Analysis will be two types. Within few minutes problems are starting. First lesson. Analysis will be two types. Posterior analysis, A silent, priori analysis. Time complexity is right. Sorry, analysis will be two types. Posterior analysis, priori analysis. So in the case of the posterior analysis, what happened is name itself saying postponement. If I ask time complexity of your program, what the posterior analysis will say is what is the language of compiler, what is the type of hardware you have to mention. In this analysis, according to posterior analysis, time complexity based on language of compiler and type of CPU. According to posterior analysis, if I want to find out time complexity, you have to know two things. Language of compiler you should know, type of CPU you should know. Actual things you should know. If you know actual thing, what is the advantage? You will get the exact answer. Right? But the problem is CPU changing. Right? Time complexity also will change. Language of compiler is changing. time complexity also will change. Post-theory analysis, if anyone asks you, say something about post-theory analysis. What is the answer? It is based on the real things. Language of compiler matters. Type of CPU matters. It is based on the real things. Suppose these two things, if you know, you can give the time complexity. These two things you don't know, you cannot give the time complexity. The advantage here is the real things you are taking into consideration. You will get exact answer. You will get exact answer. But the drawback is, right, real things are changing. Time complexity will also change. See, system to system, different answer will come. Computer to computer, different time complexity will come. If you run the program in a M5, some time complexity will come. If you run the program in some other system, some other time complexity will come. So if anyone asks you what is the post-theory analysis, in the post-theory analysis, right, we are taking real things into consideration. What are those? Language of compiler, type of CPU. Suppose those two are best two, less time you will get. Those two are worst two, right? More time you will get. So the advantage is the real things you are taking into consideration. You will get exact answer. But the problem is those two things are changing. Time complexity will change. So system to system, different answer. But see the priori analysis. Priori analysis is opposite of it. What is that one? It is independent of language of compiler and type of CPU. It's independent. Those two things, if you say or if you don't say, it doesn't matter. According to priori analysis, right? Language of compiler, type of CPU doesn't matter. Language of compiler, type of CPU doesn't matter. It is independent. Because of real things you are not taking care, you will get the approximate answer. But the advantage is in every system, same time complexity, same time complexity you will get. So analysis will be two types. Post-theory analysis, priori analysis. If you take actual things into consideration, that is called post-theory analysis. Actual things if you take into consideration, that is called post-theory analysis. This is actual. If you don't take actual things into consideration, that is called priori analysis. Right? In the priori analysis, it is independent of language of compiler, type of CPU. The advantage is same answer in every system. Time complexity of this program everywhere same time. Next one. What are the drawback? It will give approximate answer. So some theoretical things are going on. Within a few minutes, you will get the numerical things. You will get the full clarity. That I will go back and I will see one time now. What is the purpose of analysis? Analysis purpose is identifying best program or identifying best algorithm. From today onwards, if anyone asks you, purpose of analysis in algorithm, what is the answer? Identifying best algorithm. That is the purpose of analysis. So how you find out best algorithm and all? Based on two factors, time complexity, space complexity. Next question, how to find out time complexity? Time complexity based on how much time for compilation, how much time for running. Compilation is based on compiler, which is a software, which is nothing but a programming language. So time complexity based on compiler, compilation plus running. Compilation time based on the language of compiler. Means in which language compiler is written. Next one, running is based on the processor, which type of CPU you are using. Suppose these two things, real things, if you know, according to that, if you give the answer, that is called post-theory analysis. Post-theory analysis, it is a dependent on language of compiler, type of CPU. Real things you are taking, then you will get the exact answer. Problem is system to system, different time complexities will come. Priori analysis, independent of language of compiler, type of CPU. It is independent. Simple. Dependent analysis, independent analysis. Actual things if you take into consideration. Actual things if you take into consideration, that is called post-theory analysis. Actual things you don't take. Language of compiler, type of CPU, you don't take care. That is called priori analysis. Advantage is same answer in every system. Drawback is approximate answer you will get. Everywhere in life in everywhere, two models will be there. Relative analysis, right? Relative analysis. It is a relative. Relatively, how actual things are these, what will happen. Right? Relative, this is called as a relative analysis. It is the approximate analysis. It is the approximate analysis. It's the exact analysis. Why exact? Real things you are taking into consideration. Why it is approximate? Real things you are not taking into consideration. From today onwards, if anyone asks you, analysis purpose, right? Finding the best program or finding the best algorithm. How you are finding based on two factors, time and space. How you find out time complexity? Time complexity based on two people, right? So compile time plus running time. Compile time based on the compiler, running time is based on processor. Next, these are the real things which needed. If you take action based on the real things, that is called relative analysis, which is called posterior analysis. If you take the real things into analysis, and if you do relative analysis, posterior analysis, if you don't take real things, that is called priori analysis, which is called approximate analysis. Which is called approximately. Always in life is like this, relatively and approximately. Sometimes relatively may be possible. Sometimes approximately may be possible. In life, you cannot do everything every time relative only, every time approximate only, right? Sometimes maybe relative, sometimes maybe right approximately. So posterior analysis, other name, exact analysis, relative analysis, priori analysis, another name, approximate analysis, approximate analysis, or priori analysis, right? Fine. But remember, total software industry follows. Total software industry follows priori analysis. From now onwards, please concentrate. From now onwards, please concentrate. From now onwards, please be careful. I will give these notes also. I will give these notes also. You will get the clarity. From now onwards, very, very important. Industry follows priori analysis only. Time complexity, how to find out. From today onwards, if anyone asks, time complexity, how to find out using priori analysis. What is a priori analysis? Another name, approximate analysis. Means real things you don't consider. It will give approximate answer. Why it is important? Total industry follows priori analysis only. Be careful, be careful. It is a priori analysis definition. Can you see this one? Priori analysis definition. It is a determination of order of magnitude of a statement. It is a determination of order of magnitude of a statement. It is a definition. You will get within few minutes. Until now, because of examples are not started, from now onwards examples are there I am going to give. Do you have any observation, any doubts? Can you comment in the comment section? Can you comment in the comment section? No, I will train that much. I will train that much. You have to find out yourself, right? If at all any vacancies are there, my old students are saying, right? I may give reference also. I may keep on asking the seniors if they are giving any reference. We will provide that also. We will provide that also, right? If at all any doubt is there, please let me know. Let me know if any doubt is there. Till now, any doubt there, let me know. I will provide these notes also. I will provide these notes also. Let's start the first problem. Let's start the first problem. This is the problem. This is the problem. Everyone try to understand. Everyone be careful. Everyone be careful. How to find out time complexity? See this one. Priori analysis. Priori analysis, the definition also I written. It is a determination of order of magnitude of a statement. What it means, I will explain. Everyone be careful. Be careful, everyone. Everyone be careful. I'm writing now. Everyone be careful. This program time complex how much? Observe here. This program time complex how much? This is the first program. Time complex how much? Very simple. If you want to find out time complexity of any program from today onwards, right? Open bracket, close bracket, don't count them. In between, how many statements are there? Count first. Numbers give. In the right, what is the time complexity of this program? Simple. Open bracket, close bracket. In between. How many statements are there? Count. I think only one statement. Only one statement. No loop also. No loop also. While running. When I say run, while running, this statement will execute by CPU how many times? Only one statement. While running, this statement will execute by CPU how many times? One time. One time. That is called order of magnitude. While running, a statement will execute by CPU how many times? See, It is a determination of order of magnitude of a statement. Order of magnitude is nothing but while running, a statement will execute how many times? While running, statement 1 will execute one time. While running, statement 1 will execute how many times? One time. So time complexity of this program is, right? So I think whatever order of magnitude is there, write down. You can write the theta of 1 also, correct answer. You can write the big O of 1 also, that is also correct answer. You can write the omega of 1 also, all correct. Time complexity of this program is big O of 1, omega of 1, theta of 1. To find, right, to say, right, normally to represent time complexity, we will use some symbols, big O, omega, theta. We are going to discuss this afterwards. So time complexity of this program is, right, simple step, first step. You want to find out time complexity of any program? Yes, first step. How many statements are there? First of all, give numbers. One statement. Go to every statement, count how many times that statement is executing by CPU whenever it is running. Because of lack of loop, lack of recursion, this statement will execute only one time. How many times a statement is executed by CPU? That is called order of magnitude. Order of magnitude of first statement is 1. Then time complexity is nothing but whatever you got, right? To that one, just keep theta or big O or omega. While running, the statement will execute only one time. So its time complexity is big O of 1 or omega of 1 also you can write, or theta of 1 also you can write. That is the first program time complexity. You may be having some doubt. You may be having some doubt. Please let me know. You may be having some doubt. Please let me know. First program is over. How to find out time complexity? Using priori analysis. Remember, some students are asking, sir, while doing the first problem, you never asked me what is the CPU type. You never asked me what is the type of a compiler. That is the reason it is called priori analysis. That is the reason it is called as, right, approximate analysis. Sir, while doing first problem, you never asked me what is the type of CPU. You never asked me what is the type of compiler. You never asked, but you give an answer. That is the reason it is a priori analysis. Total industry follows priori analysis because of that reason. Time complexity of this program. Then what is the type of CPU? That means you are not following priori analysis. Following the posteriori analysis. A total industry follows priori analysis only. What is the priori analysis? It is completely based on order of magnitude of a statement. Time right? Remember priori analysis. Simply saying, while running a statement will execute how many times? That is called order of magnitude. So every statement, order of magnitude you find out. Based on that, we will decide the time complexity. That is called priori analysis. Priori analysis, first problem I done. You may be having some objection. You may be having some objection. Please let me know. Sir, I have this objection, sir. If you have any objection, you can say. Check everyone. First problem done. First problem done. If you have any objection, you let me know. Clearly I written. Clearly I made the notes also for you. I made the notes also for you. Any doubt? Let me know. Any doubt? Check once. Check. Yeah. If you don't have doubt, let's go to problem 2. Let's go to problem 2. Can you see the problem 2? Can you see the problem 2? Everyone, can you see the problem 2? Problem number 2 going on. Forget about this. Careful, understand everyone. Problem number 2. Problem number 2. Right? So see this one. First of all, if you want to find out time complexity of this program, first of all, give numbers. Statement number 1. Remember, statement number 1. First of all, find out how many statements are there. Right? Statement number 2. This is the statement number 1. It is statement number 2. This problem contains 2 statements. This problem contains 2 statements. People normally misunderstood. People think that there are 3 statements are there. Remember, only 2 statements are there. This program contains 2 statements. Now the question is, whenever this program is running, how many times first statement will execute? I think one time. While running this program, how many times first statement will execute? One time. While running this program, how many times second statement will execute? Every one. No, it is a part of the for loop. each I value, this statement will execute. Right? When you say it is a loop, remember, in the loop, second statement is there. When you say loop, it will execute many times. I is equal to 1, second statement will execute one time. I is equal to 2, second statement will execute one more time. And so on, it is keep on going. Language to language, only syntax will differ. In the case of the Python language, for is there, lastly colon you will keep. Lastly you will keep the colon. So in the for loop, inside you are keeping semicolon. In Python language, you may keep comma. In Python language, you may keep comma. Syntax, only syntax will differ. Now see this one. Every time how much you are incrementing, right? I plus plus. But in the case of Python language, there is no I plus plus, there is no I minus minus. You have to write I minus 1, right? You have to write I minus 1, I plus 1, something like that. There is no I plus plus, there is no I minus minus. Simply, you have to write I minus 1, or you have to do I plus 1, something like that. Or plus 1, minus 1, you have to write. In Python language, here you may write plus 1. Step count, this is called step count, minus 1. If you want to increase, plus 1. If you want to decrease, minus 1, something like that. Or anyhow, don't worry about the languages. Every language has some small syntax changes. Don't worry. Don't worry. But in algorithm subject, we are studying the logics. Just study the logics. Don't study the syntax and all. After logics are over, then automatically you can see the syntax. Now understand everyone. I is equal to 1, right? This statement, second statement, if you see, I is equal to 1, one time it will execute. I is equal to 2, I is equal to 2, one more time it will execute. One more time it will execute. I is equal to 3, one more time it will execute. It will continue. I is equal to n, one more time it will execute. So second statement is executing approximately n time. Each I value it will execute. I value 1 it will execute. I value 2 it will execute. I value 3 it will execute. So first statement will execute by CPU one time. Second statement will execute by CPU n time. So order of magnitude of both the statements are n plus 1. Simply add plus 1. Order of magnitude of both the people is n plus 1. Remember, whichever is the bigger one, you take. N plus 1. N is bigger. So time complexity of this program, big O of n. Or omega of n, theta of n. That is the answer. See this one? Your first statement will execute one time and second statement will execute n time. So total order of magnitude is n plus 1. N plus 1 can be written as, right, big O of n, omega of n, theta of n. You can write whatever way you want. All correct. Time complexity of this program is actually n plus 1. Bigger one in this is n. So time complexity is big O of n, omega of n, theta of n. Simply for every statement, find out order of magnitude. Add them. That is the right order of magnitude of total program will come. Order of magnitude of total program will come. In that, whichever is bigger, you take. N plus 1, bigger is n. So big O of n, omega of n, theta of n. You can do this. So second problem also we done. Second problem also we done. Is there anyone who is having any objection? Is there anyone who is having any objection? Please let me know. The purpose of this class is how to find out time complexity. Yeah, so you will get to know. You will get to know that one. That one also I will say. That one also I will say. First, let me complete my story. Afterwards, whatever you say, that also I will do that. First, let me complete my story. Afterwards, whatever you say, that also I will complete. First, let me say my story. Just identify how many statements are there. Two statements are there. Next one, while running by CPU. First statement will execute how many times? First statement is not part of loop, one time. Second statement will execute how many times? It is a part of the loop. I value 1 one time, I value 2 one more time, I value 3 one more time, I value 4 one more time, I value n one more time. Totally second statement executing n time. So n plus 1, total order of magnitude is n plus 1. N plus 1 can be written as big O of n, omega of n, theta of n. So time complexity of this program is whatever way you want, you can write. Big O you can write, omega you can write, theta also you can write. I hope no one having any objection until second problem. Let me know anyone having any issue. Goal is finding time complexity. Your goal is very clear. I don't want to waste your time. That is the reason this course, the course which I am going to take, right? DSA course going to take 3 months. DSA course will be over. 3 months DSA course will be over. 3 more months you will practice. Right? Within 6 months, you will become expert in the DSA. Within 6 months, you will become expert in the DSA. 3 months complete the total course. I'll go complete DSA complete. I'll go complete DSA complete and programming complete. 3 more months you do practice. Approximately 500 to right 1,000 problems you practice. Just 500 problems practice. 500 is more than enough. We'll give one more 500 for practice also. If you do that, you will be expert in the DSA. You will be expert in the DSE. I think second problem is over. Let's see the third problem. Everyone observe. Third problem, everyone observe. Everyone observe what is the third problem, time complexity. Please see this. Please see this one. First of all, identify how many statements are there. Everyone concentrate. Everyone concentrate. In the third problem, how many statements are there? First count. Statement number 1. Statement number 2. First identify how many statements are there. Loops don't count. Because of loop, that statement executing many times. Because of loop, that statement executing many times. So first statement, second statement, it is a third statement. This program contains 3 statements. Next one, whenever this program is running by CPU, how many times first statement will execute? If you want, you can check. One time only, because it is not part of the loop. So order of magnitude. Order of magnitude. Order of magnitude is 1. Order of magnitude is 1. Okay, fine. So first statement, order of magnitude is 1. We return. Can you see the second statement? Each I value 1, this will execute. I value 2, this will execute. How many times? Until n. So order of magnitude of second statement is n. Now observe here. 2 inner loops are there. Remember, this loop is n times. Each I value, right? This statement will execute n time because 2 inner loops are there. If you want, I will write also. Can you see this one? I value 1. J loop is executing. 1, 2, 3, and so on n. J loop is executing 1, but every time statement executing. So I value 1, n time statement will execute. I value 2 also check. J is equal to 1, 2, 3, and so on n. Right? Each I value, J loop is running. So next one, every J value statement will execute 1 time. Like that, it is also executing n time. So I value 1, statement executing n time. I value 2, statement executing n time. It will continue n times. This story continue n time. So every time is n, like that n times. N into n square times. So second statement order of magnitude is n square. First statement order of magnitude is 1. Second statement order of magnitude is n. Third statement order of magnitude is n square because each I value statement is executing n time. Each I value statement executes n time. So 2 times, right? I is equal to 2, 1 n. I is equal to 1, 1 more n. So 2 i's are over 2n. 3 i's are over 3n. 10 i's are over 10n. n's, right? N i's are over nn, right? So order of n square. Now order of magnitude of total program, if you observe, n square also there, n also there, 1 also there. Order of magnitude of total program, if you observe, n square plus n plus 1, right? I think in this one, bigger one is n square, right? Take the bigger one and you write. You may say that, why are you taking bigger? You may say that, why are you taking bigger? That is the reason it is called approximate analysis. Small thing, you no need to bother. Right? In your life also, small problems will come. Don't cry for everything. Whenever some big thing happens, then cry. Small thing, don't cry. You have problem, I have problem. Your friend also having problem. Small thing, don't cry. Bigger thing, cry. You want to say that. Bigger thing only, please take care. Small thing, ignore. In your life also, small problems are coming. Ignore because small thing you cannot cry. Small thing you cannot stop life. someone you propose it someone, right? They slapped you, they beaten you. Don't think much. Don't think much. Maybe you can propose to someone else. Means small thing. Don't cry. Small one subject you failed. No need to bother. Right? Just whatever mistakes you done, rectify. Small thing. Don't cry. Right? Bigger things take care. What is the priori analysis? Approximate analysis means small thing you can ignore. Every statement order of magnitude you find out, but time complexity is nothing but a larger one because this is the place where CPU is spending a lot of time. When people will say India, people will remember Delhi. Reason is valuable person means prime minister, president. All the valuable people will stay lot of time in Delhi only. When I say India, people immediately say Delhi. Are you from Delhi? When you say India, just you go abroad and you say India, oh, you are from Delhi. Means India means almost Delhi because valuable people, prime minister, right? Prime minister, president, all the people are spending a lot of time in Delhi only. So time complexity is nothing but order of magnitude of every statement, which is nothing but order of magnitude of a statement which is spending more time. Because this is the place where CPU is spending lot of time. Time complexity is nothing but right how much time CPU is spending a lot of time in a particular place. That is the time complexity. Maximum time CPU spending in the third statement. Maximum time CPU spending in the third statement. So in the third statement, CPU spending maximum time. So I think I give this explanation also. Can you see this? Can you see this one? I is equal to 1. I is equal to 1. About third statement, I explained. First statement, second statement, you know very well. About third statement, I explained. Can you see this one? I is equal to 1. J loop is n time. So I is equal to 1. N times statement will execute. I is equal to 2. N times statement will execute. Right? So like that, if you observe, similarly, this pattern or loop continue until I is equal to n. So total time complexity is the first statement order of 1, second statement order of n, third statement order of n square, overall order of n square will dominate. Time complexity of this program is order of n square. I hope third problem also people clear. I hope third problem also people clear. Little doubt also there, please ask me. Ready, sir? I have this doubt. You ask me, I will help. 3 problems I done. 3 problems I done. Time complexity of a problem. Time complexity of a problem. 3 problems I done. Do you have any doubt till now? Do you have any doubt till now? Everyone try. Do you have any doubt till now? 3 problems I done. I will give the notes also. I will give the notes also. I will give the notes also. Whatever I am saying, you no need to write anything. You no need to write anything. I will give notes also. What is the time complexity of this program? I already given. Right? 4 programs are done. Let's go to, 3 programs are done. Let's go to 4th program. Let's go to 4th program. Let's see everyone. Everyone see the 4th program. Everyone see the 4th program. One time listen, afterwards revise. Within 3 days, you will be absolutely fine with the time complexity. Can you see the 4th problem? Can you see the 4th problem? See the 4th program. So I think it is a beauty. Can you see the fourth program is a beauty? If you see this one, 1, 2, 3, 4, 5. 4th program contains 5 statements. See this one. Every statement order of magnitude is 1 because no loop. Every statement order of magnitude is 1 because there is no loop. Remember, time complexity means normally loops only. If no loop is there, listen, if no loop is there, remember, if we add all of them, I think right, I think five statement, every statement is 1, 1, 1, 1, it is 5. 5, right? There are 5 statements are there. Because of lack of loop, every statement will execute 1 time. 1 plus 1 plus 1 plus 5 times, 5 ones. So 5. Remember, every constant can be written as big O of 1. Every constant can be written as omega of 1. Remember, 1 means not 1. 1 means constant. Every constant can be written as theta of 1. Remember, 1 means not 1. 1 means constant. Remember, 1 means constant. In algorithm terminology, 1 means constant time. So time complexity of this program, big O of one also. It is an excellent problem. It is an excellent problem. Please let me know anyone having any objection. Fourth problem is an excellent problem. Some people are saying, so, sir, time complexity 5. There is no time complexity called 5. 5 means constant. Every constant has big O of 1 or omega of 1, theta of 1. Time complexity of fourth program is, right, constant 1. Right, of 1. 5 means not 5. 5 means constant. Some people are asking, suppose a tensor, that is also order of 1? Yes. Sir, suppose assume that, ready sir, suppose assume that 1000 statements are there, every statement executing one time. Then what is the answer? 1000. 1,000 times 1000. Every constant can be written as big O of 1, or omega of 1, or theta of 1. Please careful. 1 means not 1. 1 means constant. Fourth problem also completed. Fourth problem completed. Can you go to the fifth problem? See the fifth problem. It's a very, I think fifth problem also, please observe carefully. Time complexity means loops only. If no loop is there, constant time. Time complexity means loops only. If no loop is there, constant time. Let's check. So what is the time complexity of a fifth problem? Can you see this one? What is the time complexity of a fifth problem? First statement. I think order of it is not part of the loop. 1. Can you see the second statement? Can you see the second statement? Observe carefully. Observe carefully. Second statement. Second statement, if you observe, I think if you observe the second statement, it is the end time. That is also okay. Now see the third statement. I think third statement, if you observe, I think is it repetition of any change there? I is equal to 1, I less than or equal to n, I plus plus, j is equal to 1, j less than or equal to n, j plus plus, x is equal to y plus z. I think it is a normal. It is like third problem. Can you see the third problem? Third problem also same. Yeah, I think third problem, maybe. I think, yeah, it's exactly third problem. It is exactly third problem. I think no change there. No change. Maybe some repetition unknowingly repetition. Same. Answer is order of n square. I think a third statement is n square. Time complexity means a bigger one. If you add also same thing. If you add also n square plus n plus 1. Bigger one is n square. Big O of n square. That is okay. That is okay. I think it is a repetition. There is no problem. Fifth problem also over. Can you see the sixth problem? Can you see the sixth problem? Everyone concentrate. Everyone concentrate. First of all, identify. First of all, identify how many statements are there. Everyone observe. Sixth statement. First of all, how many statements? Magnitude is 1. Okay. Second statement. Understand here. Second statement. Order of magnitude is n. Now observe third statement. There is a small change. Can you see the observation? Third statement. If you see the third statement properly, I is equal to 1. If you see the j loop, j is equal to 1, j is equal to and so on. J is equal to n by 2. It's not n by 2. So for each I value, statement will execute n by 2 times. For each I value, statement will execute. J loop is n by 2 times. Statement will execute n by 2 times. So let's see here. 1, 2, and so on, n by 2. So each I value, right, statement executing n by 2 times. N by 2 times. So if you observe clearly, this will continue n times. This will continue n times. So which will goes to finally, this will goes to n times. Which will goes to finally, can you see this one? Every time n by 2, like that n time. Like that n time. Every time n by 2. Like that n time. Which will goes to n square by 2. Which will goes to n square by 2. But previous problem, if you observe, if you see this problem carefully, each I value n time. each I value n time, each I value n time, each I value n time. So n times n, each I value n time, n times n. But here n times n by 2. This one n by 2 times n square by 2. Now if you add all the people, n square by 2 plus n plus 1, n square by 2 plus n plus 1. So in this one, if you see the bigger one, n square by 2. Bigger one, if you see n square by 2. This n square by 2 can be written as 1 by 2 into n square. 1 by 2 into n square. But remember, 1 by 2 is a constant. Ignore. 1 by 2 is a constant. Ignore. Right? Remember, finally it is going to be big O of n square. Problem number 6. Problem number 6. Big O of n square. 1 by 2 into n square. 1 by 2 is a constant. So n square. You may say that, sir, n square 2 also constant. Can I ignore? But remember, for your namesake, you written n square, but it is actually n into n. It is not a constant. It is actually n into n. N square by 2. So 1 by 2 is a constant. Ignore. But n square means n into n. N into n, it is not a constant. It may be for your convenience, you written n square short. But actually, it is a n square means n into n. So you cannot write n. N into n it is. So bigger one is n square, big O of n square. Remember, time complexity is nothing but the place where CPU is spending a lot of time. See, remember, CPU is spending a lot of time here. Time complexity is nothing but in the program where CPU spends time. This is the area. This is the area. This is the area which is dominating by CPU. CPU is spending a lot of time here. So time complexity of this program is nothing but, remember, from today onwards, time complex means finding loops. If no loop is there, no loop, like fourth problem, time complexity 1. If no loop is there, time complexity 1. Suppose many loops are there, like third problem. Loops are there. See, second one is a loop, n time. Third one is a loop, n square time. So many loops are there. Take a larger loop. Time complexity means loops. Many loops, larger loop. If no loop, constant. If no loop, constant. Loop is there, larger loop you take. Sixth one, let's go to seventh one. Let's go to seventh one. Observe carefully. Observe carefully. I think safe. Observe carefully. See this? In the place of for loop, I written while loop. In the Python program also, while loop is there. In the C language also, while loop is there. Every language having loops. Can you see the loop here? Can you see the loop here? Each I value 1 onwards, I am starting. Each I value, 2 statements are executing. I value 1, 2 statements are executing. I value 2, 2 statements are executing. I value 3, 2 statements are executing. Yeah, I think, yeah, some network issue. Yeah, I hope everything is fine. Now observe. Now observe here. Now observe here. Everyone observe. Everyone observe. Each I value 2 statements. I value 1, 2 statements. I value 2, 2 statements. I value 3, 2 statements, right? Remember, if you want, you can write this also. It is a one statement. It is a one statement. It is a second statement. It is a third statement. Observe here. From now onwards, small things also I will take care. See this one. While running, this statement will execute one time. While running, this statement will execute one time. Now listen. I value 1, these 2 will execute. I value 2, see. I value 1, 2 statement will execute. I value 2, 2 statement will execute. I value 3, 2 statement will execute. So continue. How many times? N time. I value n, 2 statement will execute. Right? If you observe clearly, every time 2, like that n times. So 2n. So each I value 2. Each I value 2 people executing. So like that, like the 2 n time 2n. Some people are asking, sir, this also executing ready, sir. This also executing. Okay, count it. Count that also. You want to count that one? Count that also. So isn't that one? Every time three statements are executing. So this also executing, this also executing, this also executing. Let's see. Every time, every I value, three people executing. 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 It will become 3n. So finally, if you observe, first statement executing one time, right? Second part, if you observe, 3n time, 3n. Finally, bigger one is 3n. Finally, bigger one is 3n, but 3 is a constant. But 3 is a constant, ignore. So finally, time complexity is big O of n. That is the reason it is a 2n, 3n, doesn't matter. It is a 2n, 3n, doesn't matter. At the end of the day, 3 is a constant, we are ignoring. At the end of the day, 2 is a constant, we are ignoring. So what you do is, from now onwards, very simple story. First statement, what is the order of magnitude? 1. Assume this total, one statement. Assume this total statement, even though 3 are there, don't worry. If you take 3 also, 3n. Finally, 3n means order of n. Right? Let's take total as one statement only. So every time one statement executing, overall it became n, right? 1n. If you write 3n also okay, 1n also okay, 2n also okay, there is no objection. Simply loop is how many time? Simply loop is how many time? I think loop is n time. Time complexity means loop only. So first one, not loop, n. Second one, loop, n. Overall, larger one, n. Time complexity, big O of n. If anyone says, sir, every time 2, like that n time, 2n also correct. Sir, every time 2, like that n time, 2n correct. Sir, every time 3, na, including this also, every time 3, okay, every time 3, sir, every time 3. So it is a 3n. Finally, 1 plus 3n is 3n, bigger one. 3 is a constant, order of n. Suppose if you take 1 plus 2n, it is a 2n, bigger one is 2n. 2 is a constant, you can write a big O of n, that is also correct. Next one, some people will do like this also. 1 plus, second one. I think this loop is repeating n time, so n. So finally, bigger one is n. So time complexity is big O of n. That is also correct. All three are correct. So this program contain. Observe here. This program contain. Understand everyone. This program contain two statements. First statement is one time. Second statement is n time. Time complexity order of n. First statement is one time. One time. Second statement is n time. So time complexity is big O of n. Suppose first statement is one time. Second statement is every time 2. So finally 2n. 1 plus 2n is 2n, which can be written as order of n. Suppose including the I less than or equal to n, that also count. Every time 3, like that n time 3n. That is also correct. So these three all are correct. All at the end of the day, all will give approximately same answer. Second statement is 2n, correct answer. Second statement is 3n, correct answer. Second statement is n, correct answer. All correct. No need to confuse. All three are correct. No need to confuse. So in this program, first statement order of magnitude is 1. Second statement, what is the answer? Second statement, every time is 1, 1, 1, 1, 1, like that n time. Every time is 1, 1, 1, like that. Let me write. Every time is 1, 1, 1, 1, like that n time. That is also correct. Every time is 2, 2, 2, like that. That is also correct. Every time 2, 2 also correct. Every time 3, 3 also correct. All correct. Right? At the end of the day, all will land in the same place. Big O of n. So time complexity of the seventh program, time complexity of the seventh program, order of n. Right? Every time someone is saying that every time once are, every time you are executing one statement, assume that the total block is one statement. Every time once are, sir, every time once are, ready, sir, every time one, that is also okay. Every time once are, that is also okay. Yeah, all are correct. That is the reason it is right. That is the reason it is called approximate analysis. Every time one n. Every time is two n. Every time is three n. All correct. If you take 3n, 1 plus 3n, bigger one is 3n. 3 is the constant order of n. 1 plus 2n, bigger one is 2n. Right? 2 is a constant, big O of n. 1 plus n, 1 plus n, bigger one is n. Bigger one is n. Right? Which is going to be big O of n. All correct. Now I think some people may be having some objection. I have some doubt. You have doubt, you can ask. Ready, sir? I have some doubt. You ask me doubt, I will give the answer. Just ask doubt, I will give the answer. Someone saying silly tech. Silly tech person asked me some doubt. Silly tech, can you ask me some doubt? Whatever doubts you have previously, now you can ask. You have previously some doubt. You ask me now. Most probably you may not have. 8 problems I done. 8 problems. The purpose of this one is, right, within 3 months you will complete the total DSA. 3 months you will do practice. You will be perfect in the DSA. The purpose, right? First topic is time complexity finding. First topic is time complexity finding. First topic is time complexity finding. I done. So 7 problems are over. Let's go to 8th problem. Careful everyone. Careful everyone. 8th problem. Can you see the 8th problem? Everyone observe the 8th problem. See this 8th problem. See this 8th problem. Everyone observe. Everyone observe. So first statement order of magnitude is 1. I think if you observe here, only one statement is there. Only one. It is a keep on repeat. I think almost like n time. So order of magnitude is n. So actually n plus 1. It is a very simple one. It is actually n plus 1. Bigger one is n. So time complexity big O of n. In my opinion, today's class is just starting now. 19, 11, 25. Today's class is just starting now. So 9th problem. Start. So what is the time complexity of this program? One program is given. What is the time complexity of this program? So please, first of all, whatever language I am doing, please do it. Right? In Python language, just syntax will change. Learn the syntax. Or Java language. C, C++, Java, C++, Java almost similar. Similar will be there, but in Python, slightly little different will be there. But anyhow, all languages are directly same, right? Except syntax. Start now. This program, what will be the time complexity? This is the 9th problem. 8 problems in the last class we done. If anyone is not visited, if anyone is not done in the last class, I request you, please go through that first. If you are not done last class, I request everyone, please go through the last class. Already there, yesterday, this time I taken. 8 problems I done. Today is the 9th problem. Start now. So I value 1 started. See this one. I value 1. Okay. I less than or equal to n. That is also okay. Right? I is equal to I plus 20. So if you observe clearly, every time you are incrementing by 20. So you may be, some people may be thinking that one loop is there n time. It is not like that. But inside loop, what you are doing, that also matters. Some people are thinking that so loop is there n time. No, some loops are log n. Some loops will take only log n. Some loops will take n square. So by seeing loop, don't say n. What is happening inside loop, check. So can you see this one? So if you observe clearly, inside this loop only one statement is there, that is also okay. So first remember, time complexity means loops only. So don't worry about other people. Small statement, don't bother. Time complexity means loop only. Okay, loop is there? Yeah. Now we will see the time complexity. Everyone observe. Time complexity means loop only. Observe now. So this loop is going on. This loop contains one statement, two statement, doesn't matter. So loop is there. So this loop is repeating how many times? Let's check. So if you observe clearly, every time you are incrementing by 20. Every time you are incrementing 20, not plus 1. You are incrementing 20. So it's something like this. Let us assume that. Let us assume one simple question I want to ask you. Let us assume, right? Every time I assume that initially I have 0. Initially assume I have 0. Every time I incrementing by 20, then what the answer? 0 plus 0 becomes 20. 20 becomes 40, 40 becomes 60, 60 become 80, 80 become 100. So what I mean to say is, right? So see everyone now. 0, suppose assume n is 100. Suppose assume n is 100. So initially I value 1. So 1 less than or equal to 100, condition satisfied. So you will go inside. Observe this model. 8 problems item, they are small basics. It is a 9th problem. From now onwards, some logics will start. See what I am doing. I is equal to 1. Okay. 1 less than or equal to 100, that is true. So you will go inside. Then, right, I value becomes plus 20. So it became 21. 21 less than or equal to 100, that is also satisfied. Next one, if you go inside, 21 plus 20, it's going to be 41. 41 less than or equal to 100, that is also satisfied. Observe, don't be panic. Don't be panic. Whatever I'm saying, listen carefully. Little doubt also there, comment section, you can comment. Next one, 41 plus 20, it is going to be 61, less than or equal to 100. Next one, 61 plus 20, which is going to be 81, which is less than or equal to 100. You are incrementing every time 20. See, right, there is a one person always plus 1, plus 1, plus 1, plus 1. You will do more number of time. But this person is always plus 20, plus 20. So let's see what happened. So next one, if you observe clearly, 81 plus 20, which is going to be 101, less than or equal to 100. So this is failed. This is failed. So if you observe clearly, you are able to go inside loop. How many times? 5 times only. You are able to go inside loop only 5 times. So n value 100, every time 20 incrementing only 5 times. So what is the reason? Remember, 100 by 20. 100 by 20. If you increment always plus 20, loop is, right, loop is 100 by 20 times, which is nothing but n by 20. This loop is going on n by 20 times. N by 20 times. I think everyone know n by 20 can be written as 1 by 20 into n. N by 20 can be written as 1 by 20 into n. But everyone know 1 by 20 is a constant. So this can be written as big O of n, omega of n, theta of n. So the time complexity of this program is big O of n or omega of n, theta of n, right? So actual answer is n by 20. The actual answer is n by 20. If anyone asks what the time complexity of this program, you can simply say n by 20. If they say, can you say little more better way? N by 20 can be written as 1 by 20 into n. So 1 by 20 is a constant. So n is there. So big O of n. Theta of n, omega of n. What is the difference between these three symbols? In further classes, we will see. In further classes, I will explain what is big O, what is the omega, what is the theta, what is the difference, right? I will say afterwards. As of now, assume all three are same. So the time complexity of this, remember, time complexity means loop only. If no loop is there, time complexity is a big O of 1. If loop is there, next question, that loop is how many times? I think this loop is if at all n value 100, this loop is n by 20 times. If n value is 500, 500 by 20 times. If n value is n only, n by 20 times. So time complexity of this program n by 20, which is nothing but big O of n, omega of n, theta of n. So I give an explanation also, you can see here. You can see here. Here I is equal to I plus 1. Will repeat. I is equal to, see this one. I is equal to I plus 20. I plus 20. Not I plus 1. I is equal to I plus 20. I is equal to I plus 20 will repeat n by 20 times. First 1, next 21, next 41, next 61, and so on n. and so on n. So here the time complexity is n by 20 actually. This can be written as 1 by 20 into n, which is nothing but order of n. So problem number 9, I feel everyone got. Little doubt also there. Little doubt also there. Please let me know. You please raise the hand. I am there to help you. You just raise the hand. I am there to help you. Ready, sir? I didn't get this. Right? The purpose of this one is to clarify your doubts only. I came here. You have doubt. I came for clarifying your doubt, but you are not asking. Then why you came? Then why I came? Right? I'm taking class to help you. You came here to class. You came to the class, right, to learn. You have doubt. You are not asking. Because of you are not asking, I am not explaining. So definitely it is a serious issue if you don't ask. As a student, it is your responsibility to raise the doubt. As a teacher, I'm waiting for that incident when you ask doubt. If you ask doubt, I will help you. Question number 9, answer is actually n by 20, which is nothing but big O of n. Right? Try to understand. So question number 10 is over. If you don't have any doubt, please comment in the comment section, no doubt. If you don't have any doubt, comment in the comment section, I don't have any doubt. Yeah, this loop is running n by 20 times, which is nothing but big O of n, theta of n, omega of n, something like that. Question number 9 is over. Can you go to question number 10? Can you go to question number 10? Can you start now? Similar problem. See the similar problem? Right? I always, time complexity means loop only. Time complexity means loop only. If you observe clearly this loop, always you are incrementing by 5. So it's going to be n by 5, which is nothing but big O of n, omega of n, theta of n. So like that. Big O, omega, theta, any symbol you can use. So same thing. So the actual time complexity of this program is n by 5, which can be written as theta of n. I think problem number 10 also we done. Let's go to problem number 11. Can you go there? Can you go there? Problem number 11. Can you go there? Start. So I think if you observe clearly, listen everyone, very interesting, very interesting. You are decrementing. Decrementing doesn't matter. Loop is how many times, that matters. Decrementing doesn't matter. Loop is how many times. But when you say decrementing, remember, you started with a big number. If you start with a small number, if you decrement, right, then that loop never over. You start bigger, then you have to decrement. So that decrement, at some point of time, condition will be failed. Already bigger, you have to decrement so that condition will be failed. Right? Now let's see this one. Let us assume n value 100. Next one is n value becomes 99. Next one 98, and so on. Continue. So it is a 2. Continue. It is a 2. After 2, it became 1. I value became 1. Now 1 is greater than or equal to 1. Condition pass. Next 0. Right? 0 is greater than or equal to 1. Fail. So you passed until here. You passed until here. So loop is I think everyone know. Always you are decrementing 1. Remember, always incrementing 1 or always decrementing 1. Both are n by 1 time. Incrementing always plus 1. If you start small, increment always plus 1. If you start big, decrementing always plus 1. They both will give n by 1 time. Start bigger, then you have to decrement. But how you are decrementing? Always by 1. So n by 1, time complexity of this program, n by 1 means n time. So always you are decrementing by 1. So time complexity is n by 1. N by 1 can be written as big O of n. N by 1 can be written as big O of, right? Big O of n. Right? Remember everyone? Start bigger, then you have to do subtraction inside loop. Start smaller, then you have to do addition in the loop. But whether you do n minus 1, whether you do n, right? See, whether you do I plus 1, whether you do I minus 1, both will be time complexity n by 1. See, addition or subtraction, both are same. The only difference is that addition initialization should be from small number. Subtraction initialization will be some big number. That is the only difference. Whether you do -1, whether you do +1, both will take time complexity n by 1. If at all subtraction, oh, you are subtracting, means you are decrementing, starting with big number. Then you are decrementing, some point of time it will stop. Right, like that. So question number 11 answer is N. What is the question number 12? Similar. Can you try the question number 12? Question number 12. Can you try this? Question number 12. Can you try this? Don't worry about this. Question number 12. Please understand. Try to catch everyone. Everyone try to catch this. Try to catch everyone this problem. Question number 12. You may see some interesting thing. You may see some interesting thing. See this one? Starting from big number, okay? You are starting from big number means you have to do subtraction. You have to decrement. Not subtraction. You have to decrement. Let's see how you are decrementing. First you are decrementing 5. I minus 5 you are doing. First you are decrementing 5. Next you are decrementing up for the existing value. You are doing one more -7. For the existing value, one more -50 you are doing. Total, I think -5, -7, -12, -12, -50, -62. So overall, the story is going to be, always you are decrementing by I is equal to I minus 62. Always you are decrementing by 62. See, start from big number, you have to subtract. Subtracting, okay. Subtracting by how much? Always you are decrementing 62. This is nothing but time complexity n by 62. Addition, subtraction, both are same. Addition, start with small, then keep on add. Subtraction, start from big, then keep on subtract. But both, if you do I plus 62, n by 62, I minus 62, n by 62. So time complexity is going to be big O of n. Big O of n, omega of n, theta of n, something like that. In the last class, I done 8 problems. Today, I am going to cover 10 or 15 problems. 10 or 15 problems I am going to cover. So make sure if you understand yesterday's class and today's class, you are most probably okay with the time complexity finding. Small doubt also there, you can ask me. In the comment section, please comment. Little doubt also there, comment in the comment section. Little doubt also there, comment in the comment section. Right? Perfect. Question number 12, we are already done. Right? Question number 12, already we done. Time complexity, big O of n. Go to the, I think, total explanation also given. See, total explanation, total became 62. If n is right, n is isn't that 124, 124 minus 62, 62 minus 62. So 0, I think you done the 2 times. Just you done only 2 times. Right? First you tried this. One. Right? Initially, I think, right, 62 less than or equal to 124. Right? One time you done. Next one, if you observe, it became 124. 124 less than or equal to 124. Lastly, I think it became, right? It became 124 plus 64. I think it's going to be 188 maybe. Right? Sorry, 186. Less than or equal to 124 fail. So stop. So 2 times you done, which is going to be n by 62. So same answer. So time complexity is actually n by 62, which is nothing but a big O of n. Okay, question number 12 also completed. Can you go to question number 13? See the question number 13. Everyone understand? Everyone try to understand the question number 32. Sorry, question number 13. Everyone try to understand question number 13. See the answer. Starting from big. Understand everyone? If you start from big number, you have to inside decrement. See how he is decrementing. First he is doing I minus 7. See the answer. First he is doing I minus 7. Right? Already I minus 7 you done. To that he is doing plus 9. Whatever you have, plus 9. Now whatever you have, again minus 50. Whatever you have, plus 60. So first you done the minus 7. Further you add the plus 9. Further you done the minus 50. Further you done the plus 60. Can you see overall how much? What is the overall value? Check. Minus 7 plus 9 minus 50 plus 60. Minus 50 plus 60, 10. 10 plus 9, 19. 19 minus 7. 19 minus 7, which is going to be 12. which is going to be 12. So I plus 12 overall became I plus 12. So I think this overall value became I is equal to I plus 12. This overall became I is equal to I plus 12. But understand one interesting thing. Everyone try to understand. Very important question here. This is going to be very important problem. Question number 13 is going to be very important problem. See, already you started with big number. Already you started with big number. But overall, if you observe, every round you are incrementing 12. Every round you are incrementing 12. Remember, time complexity not related to any programming language. Time complexity related to logic. Time complexity related to logic. It does not belongs to any programming language. This loop is how many time? Already I is big number. Every time you are adding plus 12. Suppose assume it is 1 lakh. Suppose assume, yeah, maybe 1000. Assume that it is 1000. Already n is 1000. Already I is 1000. After every round, 12 is incremented. See, 1000 is greater than 1. 1000 is greater than or equal to 1. Yes. 1012 is greater than or equal to 1. Yes. 1024 is greater than or equal to 1. So I think this loop never over. It will go to infinite loop. Remember everyone, this algorithm never stop. Remember, a code where it never stop. That means it is not algorithm. Algorithm means it should stop. So this algorithm taking infinite time, which is nothing but indirect way of saying it is not the algorithm. It is not algorithm. So we cannot find time complexity. It is not algorithm because it is not stopping. Algorithm first property, it should stop because it is not stopping. Because it is not stopping. Algorithm means it should stop. It is not stopping. Please try to understand. It is not the algorithm because it is not stopping. Right? Careful. It is not an algorithm because it is not solved. So we cannot find time complexity. So we cannot find time complexity. It is not algorithm because it is not stopping. So we cannot find time complexity, which is nothing but, if you want to say little more better way, which is nothing but infinite time complexity. The time complexity of this program is infinite, which is nothing but undefined. Why it is not algorithm? Because it is not stopping. It is a very good question. Question number 13 is very important. If I don't cover somewhere, you may find out some difficulty. Somewhere you may say that, sir, why it is infinite, sir? Already you started with a big number. You are always keep on incrementing. Already big number. 1000 greater than or equal to 1. Assume n is 1000. 1000 greater than or equal to 1? Yes. Next round. 1012 greater than or equal to 1? Yes. 1024 greater than or equal to 1? Yes. 1036 greater than or equal to 1? Continue. Infinite time. So the time complexity of this program is undefined. Undefined means infinite. Time complexity of this program is undefined. Undefined means infinite. Why? It is not algorithm because it is not stopping. So we cannot find out time complexity. Understand, these all three lines are same. These all 3 lines or 4 lines are same. Time complexity of this program undefined. Time complexity of this program undefined. Time complexity of this program infinite. Time complexity of this program, we cannot find time complexity because it is not stopping. These all meanings are same. Some people will say time complexity infinite. Some people will say time complexity undefined. Some people will say time complexity we cannot calculate. Some people will say it is not an algorithm at all because it is not stopping. All are correct. For the question number 13, answer is all undefined, infinite. We cannot find out time complexity because it is not an algorithm. All are same meaning. Question number 13 also we done. Question number 13 also we done. Can you go to question number 14? Can you go to question number 14? See the question number 14. See the question number 14. I is equal to 1. Okay, see this one. You started from small number. You started from small number. I think most probably inside loop. Most probably inside loop. You are increasing. Increasing. That may be addition, but you are increasing. Let's check. So first you done I plus 7. Okay. First you done I plus 7. For that plus 9 you done. For that plus 25 you done. Yeah, overall check 7 plus 9, which is going to be 16. 16 plus 5, I think 36, 41. I think this total is 41. This total became 41. Which became, the meaning of this line is I is equal to I plus 41. So this total became indirectly I is equal to I plus 41. So I think every time you are incrementing by 41, remember already you started with small. You are always incrementing by 41, right? 41, 41, 41 increasing. At some point of time condition true, further it will fail. So answer is going to be n by 41. Time complexity of this program n by 41. So which is nothing but order of n. Which is nothing but order of n. Fine. 14 also we done. Almost everyone is comfortable. Almost everyone. Anyone having any doubt, please comment in the comment section. Anyone having any doubt, please comment in the comment section. Can you go to the question number 15? Can you go to question number 15? 14 done. Go to the 15. Starting with small. See this one. First you done the increment 10. Okay. Just give 1 minute. Just give 1 minute. Right, perfect. Question number 15, see the question number 15. First you are incrementing 10. First you are incrementing 10, okay. Afterwards you are incrementing plus 20 also, yes. Afterward you are incrementing plus 30 also, yes. Overall is 60 incremented, yes. So answer is going to be always you are incrementing 60, n by 60. So time complexity big O of n. Right, I think all logics, remember you are learning all logics now. Now you are learning all logics. Comparing yesterday, today you are learning some more logics. Yesterday some logics, today some more logics. Question number 16 also, 15 also we done. Can you see the question number 16? Can you see the question number 16? I is equal to 1. Right? Now listen, one more new logic. New logic is started. Right? New logic. I think everyone know, everyone comfortable with the addition and subtraction. Do you have any doubt? Addition, subtraction done. Some other model is starting now. Addition, subtraction is done. Some other model is starting now. Some other model is starting now. Everyone observe. Some other model is starting. Right? I think until now addition, subtraction, same. Addition, start with small number, keep on add. Subtraction, start from big number, keep on subtract. Now new model is starting. It's a one more variation. It's a one more variation. New model is starting. One more variation. Can you see this? New model is coming, one more variation. Everyone observe. One more variation is going on. See this? Always you are doing a double. It is not adding plus 5. It is not adding plus 20. It is a double. What is the meaning of double? If n value 1 lakh, double means in the next round 2 lakh. N value 1 lakh. In the next round, right? In the immediate next round, it will become 2 lakh. N value 2 lakh in the next round, double. Into double 4 lakh. 4 lakh, see 2 lakh become 4 lakh in one round only. 4 lakh become 8 lakh in one round only. 8 lakh become 16 lakh in one round only. So remember, it look like very small, but it will affect a lot. It will affect a lot. So see this one. Initially I value 1. Next it became double 1 into 2, 2. Next time it became double 2 into 2, 2 square. Next time 2 square into 2, 2 cube. Next time 2 cube into 2, 2 power 4. Continue. Let us assume I continued 4 times 2 power 4, k times 2 power k. Assume I continued k time, it became 2 power k. Increasing, 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 it became 2 power k after k time. Assume this became n. So termination condition. After doing k time, right? Then both became equal. So what is the k? So I done k time, then both became equal. After doing k time, it became both are equal. K times I done. If I do 1 time, 2 power 1. If I do 2 time, 2 square. If I do 3 time, 2 cube. If I do 4 time, 2 power 4. If I do k time, 2 power k. After doing k time, 2 power k, which is become n. So in the next round, it will fail. In the next round, it will fail. So k times you done, then this is the story. What is the k value? So apply log n base to both the side. Log 2 power k base 2. Apply log base to both the side. It became log n base 2. So it became k into log 2 base 2, which is 1, which is equal to log n base 2. So k became log n base 2. Remember, this loop is repeating log n base 2 time. This loop is repeating log n k times you repeated. This loop is repeating log n base 2 time. So time complexity became big O of log n. Time complexity became big O of log n. Right? This loop is repeating log n base 2 time. So time complexity became big O of log n base 2. Right? See the total story. See the total story. See the total story. So first time 1, right? So initially 1, next into 2, next into 2, next into 2, next into 2, and so on, and so on. K times I done. It is the n which is 2 power k. After doing k time, it became 2 power k. After doing k time, it became 2 power k. After k iterations, the value of I will be 2 power k. Yes, exactly. Then this is the relation which happened. Apply log base to both the side. It became k became log n base 2. So you repeated k time, which is nothing but log n base 2 time. Afterward, this loop is terminated. So time complexity big O of log n. This is the new variation. Please be careful. It is a new variation. Please be careful. So the time complexity of problem number 16. Problem number 16 time complexity became log n base 2. Problem number 16 time complexity became log n base 2. Let me know anyone having any objection. You may be having doubt. To me, they are very simple because many times I done. To me, they are very simple because I done many times. I done many times. To me, they are very simple. So time complexity of question number 16 log n base 2. Time complexity of question number 16 log n base 2. Little doubt also there. Please go through it. I will give the notes also. If anyone want notes, you can ping me. You can ping me. I will give the notes also. Right? Fine. Go to the question number 17. Go to the question number 17. Everyone try to understand. See the question number 17. And I want to say one important thing to all of you. Right? I want to say one important thing to all of you. DSA course. Right? DSA course. Right? The DSA course is started now. DSA course is started now. DSA course is started now. So within 3 months, you are able to complete the total DSA. Within 2 months, sorry, within 3 months, total DSA will be completed. 3 more months you will practice. Then everything is all right. Within 3 months, you will become DSA expert. 3 more months, do practice. You are going to be extraordinary in the DSA course. You are going to be extraordinary in the DSA course. Right? So 80% discount going on, you can utilize. 80% discount going on, you can utilize it. Go to exampreptool.com, DSA course you can take with system design. You are going to finish all the things. Right? I is equal to 1, while I less than or equal to n, I is equal to 3 into I. I is equal to 3 into I. So I think same problem. Can you see this one? Same problem. If you observe clearly, same thing one more time I am doing, please see. Initially 1. 1 into 3, 3. You are doing a triple every time. Into 3, so 3 square. Initially 1, okay. After 1 time 3 power 1, 2 time 3 square, 3 time 3 cube, 4 time 3 power 4. If you do k time, k time 3 power k. If you do k time 3 power k, which is equal to n. So I think if you I want k times I done, what is the k value? K times I done, what is the K value? K times I done, what is the K value? So I think if you see the K, if you want something which is there in the power, if you want, right? So you have to apply log so that it will fall down. So it will become K log 3 base 3. Apply log 3 base 3. Right? Apply log base 3 both the side. It became K log 3 base 3. It became log n base 3. So finally K became log n base 3. K became log n base 3. Simple, simple. Simple. Every time into 2 log n base 2. Every time into 3 log n base 3 series. Every time into 2 multiplication into 2 log n base 2. Into 3 log n base 3. Into 10 log n base 10. Into 20 log n base 20. Because series will come like that. So if at all into 2, powers of 2 will come. Into 3, powers of 3 will come. 3 power 1, 3 square, 3 cube, and so on. So finally 3 power k is equal to n. Finally, k became log n base 3. Right? Time complexity is big O of log n base 3. I hope everyone is comfortable. Everyone is comfortable. Right. Let's move to problem number 18. Let's move to problem number 18. Can you see the problem number 18? Everyone observe. Can you see the problem number 18? First you done 2 into I. You made double. Whatever you have into 3 you done. This is the new I. I is equal to 2 into I. It is a new I. For the new I, you done into 3. Into 3 you done. It became overall, if you observe, right? It became I is equal to 6 into I you done overall. It became I into 6 into I. It became I into 6 into I. Right? Then I think this is nothing but this. Always you are multiplying by 6. Always you are multiplying by 2 log n base 2. Always you are multiplying by 3 log n base 3. Always you are multiplying by 6. It became log n base 6. It became log n base 6. Big O of. It became log n base 6. Big O of. Always into 2 log n base 2. Always into 3 log n base 3. Always into 6 log n base 6. So same. I think if you observe clearly, you will get the powers of 6. Right? 6 you will get. See, 6 power 1. Right? Next one 6 square. Next one 6 cube. Finally 6 power k. Finally 6 power k is equal to n. K became log n base 6. Excellent. Till now excellent. 18 problems we done. Till now we done the 18 problem. The purpose of this, within 3 months you will become expert in DSA. Don't cry in the social media. Every YouTube person will say whatever they want. Every YouTube person will make the DSA very complex. I guided from the 15 years onwards lakhs of people. I will guide you also. If you want to be expert in the DSA, within 3 months I will make you DSA expert. 3 months only. Just give 3 months. You will become a DSA expert. Whatever I will say, just do that. Whatever I will say, just do that. 3 months you will become expert. 3 more months you do practice. More than enough. Question number 18 also done. Go to the question number 19. Question number 18 we done. Go to the question number 19. Everyone observe. Everyone observe what is the question number 19. See the question number 19. Remember everyone. Everyone observe. Very interesting. Very interesting. See this. Very interesting. Start from small. See this one. Start from small. 1. Everyone observe. 1 into 2. Again into 2. 2 square. Again into 2. 2 power 3. Again into 2. So 2 power 4. And so on. Assume. And so on. 2 power k. K times 100. 2 power k. Everyone know this program. If at all always into 2. Log n base 2. Time complexity becomes log n base 2. Everyone know this. Time complexity became log n base 2. Everyone know this. Always you are doing into 2. Log n base 2. That is okay. So if you start from upper, where small number. If you start from small number, always into 2. Log n base 2. If you start from big number, always divide 2. If you divide always 2. 2 power k by 2. 2 power k minus 1. Again by 2. 2 power k minus 2. And so on. 2 power 1. And so on. Right? 2 power 0. So this is also log n base 2. Remember, you always will see whether you do into 2, whether you make a double, whether you make a half, both are same. Addition reverse is subtraction. Multiplication reverse is division. Into 2 reverse is divide 2. Start from small number, always double log n base 2. Start from big number. See, he started n. 2 power k means n. He started from n. Always you make half. Always you make half. That is also same story. The only thing is the reverse order. If you start from small number, always double. So 2 power 1, 2 square and so on, 2 power k. If at all, if you start from big number, always half. By 2, by 2, by 2, by 2, by 2, it will be like that. It will be like this. So n is equal to 2 power k will become log n base 2. Same answer, same answer. Some people are asking, sir, can you explain? I will explain. See, first n. See the proof, same story, first n. Next became, right? Next became whatever you have, by 2 you do. Whatever you have by 2, next n by 2. Next one, whatever you have by 2 you do. By 2 means n by 2 square. Whatever you have again by 2 you do. N by 2 square by 2, n by 2 cube. N by 2 cube. Continue. If you do k time, it became n by 2 power k. Right? And some people are asking, sir, you are decrementing. Lastly, it became 1. Termination condition. See, I think 1, right? 1 greater than 1 condition is failed. So until 1 continue. So continue. Finally, n is equal to 2 power k. So log n base 2 is equal to k. Same story. Log n base 2 is equal to k. What I mean to say is, whether you do into 2 or whether you do divide 2, both are same. If you do into 2, it is increasing. Start from small, always double. That is also log n. Start from big n, always do half. That is also log n base 2. This is the proof. So in the case of the double, power is incrementing upper. See, power incrementing upper. In the case of double or triple, power incrementing upper. In the case of divide, power incrementing niche. See, 2 power 1, niche see, n by 2 power 1, n by 2 square, n by 2 cube. This is the only difference. At the end of the day, both are log n base 2. Right? N by 2 power k is equal to 1, n is equal to 2 power k becomes log n base 2, time complexity becomes log n. So problem number 19 also you done. Problem number 19 also you done. Problem number 19 also you done. Can you go to problem number 20? Can you go to problem number 20? Almost similar. We'll do this also. Let me remove unnecessary. Right. Now see the answer. I think same story. See this one. Same story. Everyone listen. You are doing by 2. Okay. Whatever you have by 2, again that one you are doing by 3. So which became I by 6. Which became I by 6. I is equal to I by 6. Right? Initially you done by 2. Okay. To on that again you are doing by 3, which finally became I is equal to I by 6, always by 6, which will become log n base 6. Same story, log n base 6. Question number 20, answer is log n base 6. Question number 20, answer is log n base 6. Right? I think time complexity of this one is, see, if you want you can check. First n, next n by 6, next n by 6 square, next n by 6 cube and so on. Finally, n by 6 power k is equal to 1. Finally, n is equal to 6 power k. So finally, k becomes log n base 2. Log n base 6. Therefore, time complexity because of log n base 6. 20 also we done. Let's go to 21. Let's go to 21. Everyone understand? 21. I think, yeah, this may be the last problem. Observe here. 21. Question number 21. Can you see one time? First two, I by 5. Remember, you started with a big number. Means inside should decrease. What is happening? We'll check. You started with a very big number. Inside you should decrease. Then only termination condition you will see. See what is happening. First you done by 5. Okay. Okay. Whatever you have, you done by 7 also. Right? Which is nothing but I by 35. 5 sevens 35. Check properly. Next one. Whatever you have, you done again by 2. which became I by 70. Now next one, whatever you have, again you done by 2, which became I by 140. I by 140. Now understand, whatever you have into 4 you done. Into 4 you done. Please check properly. Into 4. Then what is the answer? Right? I think 4 ones, 4 twos, sorry, 4 threes, 12. Now 4 fives. I think 35. 35. This became I by 35. Overall I by 35. So what I mean to say is, already you started with a big number, right? Overall, every time you are dividing by 35. Always dividing by 35. Answer is, right, log n base 35. Log n base 35. Log n base 35. Careful. Always you are dividing by 35. Log n base 35. So see this one. After k iterations, I value, right, it will become n by 30 power 35 power k is equal to 1. Finally, n is equal to 30 power k. Finally, k becomes log n base 35. Time complexity becomes log n base 35. See, so many problems. 21 problems I done. They are very, very easy. Very, very easy. Very, very easy. Yesterday's class you see, today's class also you will see. Almost you got what is the meaning of time complexity. Question number 22. Yeah, start now. See the problem one time. See the problem one time. Yesterday we done. It's the continuation of the yesterday's class. So I is equal to I by 2, I is equal to I by 7. If you observe, first by 2, next by 7. It's totally, right? I think I by, totally I by 14. So it is equal to, I is equal to I by 14. Means overall I is decrementing. Overall I is decrementing. That means initial I value is a bigger number because you are decrementing. You are decrementing means initial I value is a bigger number. So in the loop you are decrementing until termination condition happened. Termination condition is I greater than 75. So I value becomes 75, 75 greater than 75, condition fail. So I think everyone know, if you always divide by 14, 14, 14, I think time complexity becomes log n base 14. You know this very well. Time complexity log n base 14. If you want, you can do the proof also. If you want, you can do the proof also, right? I think most probably it is done. So you can verify yourself, right? It became the series n by 14 power k is equal to 75. Decrementing until n by 14 power k is equal to 75. So it become n is equal to 75 into 14 power k. So log n base 2 is equal to, log n base 14 is equal to, right? I think it will become k plus log 75 base 14. Right? Finally, k becomes log n base 14. Remaining is anyhow some constant. Right? Finally, answer is going to be log, right? Log, right? If you observe clearly, so it is a log a by b formula kind of thing. Log a by b formula. It became log n by 75 base 14. Right? Yeah, indirectly, it is going to be log n base 14 only. Simple. No need to do this much work. I given proof purpose. I given for your convenience everything. Simple. Every time you are dividing by 14. Always divide by 14, 14, 14, 14. So answer is log n base 14. If you want a actual thing, this is the thing. First n will be there. Next n by 14 will be there. Next n by 14 square will be there. And so on. If you do 2 times, this is the story. If you do k time, n by 14 power k, which became termination condition 75. Right? I think this is the story. From here onwards, normal. All the total story I written. See. So time complexity of question number 22, log n base 14. Right? And one more, anyhow 14 is a constant, no need to bother also. If this is there in the option, you select. If not there, you can simply write like this also. Log n, that's it. Forget about base. Simply you can write log n. So question number 22, answer is log n. If at all anyone asks you, say base also, then log n base 14. If anyone asks you, say clearly, right, I don't want log n base 14, can you say one more step before? Then say this. Log n by 75 base 14. right? How you got like this? This is log a, right? Log a by b formula. Log a by b base c is equal to log a base c minus log b base c. Same thing like that, right? Same thing like this. Log a by b base c, same formula. Log a base c minus log b base c, same story. So like that it came, right? Please verify properly. Small doubt also there in the comment section, you can comment. So question number 22 I done. What is the question number 23? Go to the question number 23. Everyone try to see this one. Question number 23. I is equal to 270. While I less than n, I is equal to 2 into I is equal to 3 into I is equal to 4 into I is equal to 270, while I less than n, I is equal to 2 into I is equal to 3 into I is equal to 4 into I. I think if you observe clearly, first 2 into I, for that into 3, for that into 4, finally 2, 3, 6, 6, 4, 24. So this became, you know, very well. This became, you know, very well. So what is the answer? I is equal to 24 into I is equal to 24 into I. Always multiply by 4. But your increasing means initial I value small. Small means some constant. It need not be 1. When I say small, it need not be 1. It may be 2, it may be 3. Some constant. In algorithm terminology, every constant is same. Either a 1 or a 10 or a 25, 36, whatever it is. Or 270 or 100, 1 lakh, whatever it is. Every constant is same. Don't think much about that constant. Some constant will be there. So initially I is equal to 270, then I is keep on incrementing every time by into 24. Into 24. I think always multiply by 24. Everyone know, right? Into 2 is nothing but divide by 2. The only thing is start from big number, you will divide. Start from small number, you will multiply. So answer is going to be log n base 24. Answer is log n base 24. If you want clear, just go for the proof. You want clarity, then every time you no need to do right proof and all. Really required, then only do. So if you see the series, it is something like, if you see the series, something like it is coming, right? 24 power 1, 24 power 2, and so on. 24 power k will come, right? 24 power k will come, right? Something like that. So this kind of thing, finally log n base 24 will come. Every time proof not required. If you really required, whatever way I done in the previous, right, in the previous, for the previous problem, do similar way. Whatever I done for the previous problem, do similar way. How? If you want, you can check. I think only for namesake I am doing. No namesake. First to 270. Next to 270 into 24 power 1. Next to 270 into 24 power 2. If I continue k time, 270 into 24 power k. Increasing, it became n. Right? It became n. Now you want k value. Apply log, same story. Log n base 24 is equal to, right? It became log 270 base 24, right? It is a log AB formula plus k. Log of AB is equal to log A plus log B. Log A plus log B. So it became like that. Finally, k is equal to log n base 24 minus log 270 base 24. Right? Common base. I think same story, which will goes to, right, log n by 270 base 24. Same story like above problem. Same story like above problem, right? Which will goes to, right, n by 270, which is nothing but n. Log n base 24. If you don't bother about base, simply you can write log n also. Simply you can write log n also. I hope everyone is comfortable. Same story. Always dividing by 24. Log n base 24. Right? If log n base 24 there in the option, well and good. Otherwise you can write simply log n. Simply you can write log n. Question number 23 also I done. Go to the question number 24. Go to the question number 24. Go to the question number 24. Right? Main. I is equal to 2. While I less than n, I is equal to I square. Here the series of iteration of I goes as 2, 2 square, 2 power 4 and so on. So I think you can see this. This problem, it is a new model. Everyone can see. It is a new model. This problem is the new model. Until now multiplication division is over. Until now multiplication division is over. Now you can see. Until now multiplication and division is over. Now new model is coming, power coming. See, every time, right? Every time. Previously 2 into I. Now I power 2. I think it is incrementing so faster. If at all always into 2, into 2, into 2, it became log n base 2. But it is not into 2. I power 2, power will increase more. Suppose assume, right? I value 10. So 10 into 2 is 20. 10 plus 2 is 12. But 10 power 2, 10 square 100. There is a big change. Right? If I do plus 2, 10 plus 2 is 12. If I do into 2, 10 into 2 is 20. Comparing to 12, 20 is going more faster. More faster means less time complexity. If you do any work with faster, definitely less time it will take. Suppose, right, 10 power 2, 100. One is 12, another is 20, another is 100. So someone is going so faster. So time complexity is very less. So here always power 2, always power 2, always power 2. If you observe clearly, this will leads to log n. Proof also available. If you want, I will explain also. See, already I written also. Already I written log n is the answer. If you want, I will give the proof also. I written already. I will explain here. Can you see this one? I will explain. Initially, I value 2. Everyone observe. Initially, I value 2. Then whatever you have, whole power 2, it became 4. Whatever you have, again whole power 2, 4 square 16. Whatever you have, whole power 2 again, so 16 square 256. So whatever you have, whole square. Whatever you have, whole square. Now if you observe clearly this one, it became 2 power 0. 2 power 0 is 1, 2 power 1 is 2. This one if you observe, if you want you can check. 2 power 1. 2 power 1 is 2. 2 power 2 is 4. This one if you observe, 2 power 2 square. 2 square is 4. 2 power 4 is 16. This can be written as 2 power 2 cube. 2 cube is 8. 2 power 8 is 256. I think if I do 3 times, it is a 2 power 3. If I do 2 times, 2 power 2. If I do k time, this became 2 power k. If I do k time, it became 2 power k. Increasing, something like that. Finally, right, after increasing so many times, this became n. Equal to n, you can stop it. Equal to n, you can stop it. I think that's what it done. See, same thing it done. I think, but if you observe clearly here, 2 powers are there. 2 power k. 2 power k. Because of 2 powers, you have to apply 2 logs. Because of 2 powers are there, you have to apply 2 logs. When you apply first time, you will go. When you apply second time, you will go. So 2 times you have to apply log. So see this one, 2 power k is equal to n. If you apply log base to 1 time, so it became log n base to right side. Left side is 2 power k into log 2 base 2, which is 1. If you apply one more time, log n base 2 left side, k into log 2 base 2, it became 1. Right? Finally, log n base 2. So k is log n base 2. So time complexity log n base 2 base 2. Right? So if you want, you can write the log of log n also. Log of log n also you can write. Log of log n also you can write. Base if you don't write also no problem, because anyhow it is constant. So it's an excellent problem. It is an excellent problem. And one more thing everyone. One more thing observe here. Why are you applying first time log base 2 to eliminate this 2? Why are you applying second time also log to eliminate this 2? To eliminate the base, first base, to eliminate the base to this 2, I am applying first base as 2. To eliminate one more time these 2, right? I applied second time also 2. Inner one is the first one, right? Outer one is the last one. You may say that, why these 2 came first? What is the reason? That 2 came from here, starting one. Why second power also? See this one, these 2 came from because of this reason. Next one, some people are asking, these 2 came from here, okay, from where these 2 came? These 2 came from here, these 2 came from here. Inner loop 2 came in the power, right? Outside 2 came, right, starting base, right, like that. So if you, for more clarity, you can see the next problem. See the question number 25. 24 we done. I think everyone knows. See, very simple. In the power, answer is log n. Understand? In the power, right? You are incrementing always by power. Answer is log n. For more clarity, you can see this problem. For more clarity, you can see this problem. See, always I is equal to I power 3. Always I is equal to I power 3. Remember, inner base will come this one. Outer base will come from this. Right? So answer, if you want, you can check log of log n, inner base, right? Log of log n, inner base, if you observe, inner base 25, outer base 3. Right? This person is power, na? He will come after some time. But this person is direct, starting itself, he will come. So inner one means starting, 25. Outer one means outs, right? Lastly, he will come. So 3. So answer is big O of log n. If you want base also, inner base 25, outer base 3. If you want proof also available here, you can check properly here. Properly. So how the series will start? Very simple. 25 here. Next one, 25, 3 power 1. 25, 3 power 2. Check properly if you want. Continue k times. 25, 3 power k. It will become like this. Apply log. So remember, inner, right? Initial one is 25. Apply log base 25. So that he will go. Next one, I think now this person fall down. Now apply base 3. Then, right, when you apply base 3, right, I think he will also go. Log 3, base 3 also will go. So finally, k is log n. Inner base is 25, outer base is 3. Right? If at all it is there in the option, it's okay. Otherwise, answer is log of log n. Log of log n base 2. Log of log n base 2. Right? I think inner, right? If at all, right, this is already there, it's okay. Otherwise, base also you no need to write. Otherwise, base also you no need to write. So question number 25 also over. Go to the question number 26. Go to question number 26. Question number 26. 25 over. Go to the question number 26. Right? I think remember power reverse is root. I square, right? I square. Initially I is there. If I do square, it became I square. If I do root, it became I. So what I mean to say is square, whatever way increasing. If I do root, same way it will decrease. Same way will decrease. Let's check here. 2, square it, 4, square it, 16, square it, 256, square it, 256 whole square. 256 whole square. This is if you do square, right? If you do root, reverse. Both will be log n. Both are log n. Both are log of log n. Both are log of log n. Try to understand. Both are log of log n. Both are log of log n. Right? Whatever way square is doing, root also will do same. The only thing is, right? If at all small, square it. If at all big, root it. This is the only difference, right? Otherwise, both are same. In my opinion, both are same, right? I think you can see the proof also. See the proof. See the proof one time. I is initially n. Right? Next one, n power 1 by 2. Same story. Don't by heart anything. Until you are confirmed, keep on do proof. When you confirm, directly do. N first 2. Next one, n power 1 by 2. Next one, n power 1 by 2 cube. n power 1 by 2 cube. Next one, n power 1 by 2 power 4. If I do 4 times, this is the story. If I do k time, n power 1 by 2 power k. Remember, decreasing, it became 2. It became 2 until continue. So same story. Same story. Now remember, you are able to see these 2 first. Apply base 2. Apply base 2. Log 2 base 2 becomes 1. Next one, I think this person will fall down. This person will fall down. So it became like this. Again to make him as, right, again 1. Apply log 2 base 2 again. Right, log 2 apply. Right, then it became 1. 2 times. Finally, k becomes log n. Base 2 base 2. Remember everyone, this base starting 1 is inner 2. Right, in the power 2 is outer 1. Starting 1 is going to be inner 1, right? Power 1 is outer 1. So answer is log n base 2. Both are base 2. So k is time complexity log n base 2 base 2. If you can write like that, it's okay. Otherwise, without base also you can write. Log of log n. Remember, root reverse is square. Square reverse is root. Both will give same time complexity. Both will give same time complexity. Try to understand. Question number 26 also done. Question number 26 also done. Can you go to question number 27? Can you go to question number 27? Everyone try to understand. Go to question number 27. Right? Same thing one more time. Very, very interesting. Some people are asking, sir, before starting, can you say the time complexity directly? Before starting, can you say the time complexity directly? See this one? I think root or power, both will be same time complexity. Log of log n. Both will be same time complexity. Log of log n. That is okay. But remember, right? Remember everyone, starting 1. I think this number I am able to see because he is not there in the power. So this person whom I can see directly, that person is inner. The person who is there in the power, whoever is there, that person is outer. So answer is big O of log n. Inner one is 64, outer one 51. If you want, you can do proof also. Whatever way I done over, you can do here also. Some people are asking, sir, how, sir? Can you see this one? N first. Next one, n power 1 by 51. Next one, n power 1 by 51 square. Next one, n power 1 by 51 cube. Continue. N power 1 by 51 whole power k. Decreasing, almost equal to 64. Stop it. Remember, this person is there in the upper. So this number only I am able to see first. So I have to eliminate this number. So log 64 apply first. Okay. Next apply. This number will fall down. Then apply, right? Log base 51 you do this one. So answer is log n. Base 64 inside, base 51 outside. Right? That is the answer. Perfect. Go to the question number 28. I think everyone observe. See this one. You are starting with small number. Means inside the loop you have to increment. Increment means power. Understand? So first to I power 31. Okay. Now whatever you have, to that whole square. Remember, a power m whole power n. A power mn. So multiply. It became I power 62. Whatever you have, whole power 3. A power m whole power n. A power mn. Right? I power 62 into 3. Which is going to be, I think 3 2 6 3 16 18. So 186 I think. So I power 186. 3 2 6 3 6 18. I power 186. So answer is always power 186. Answer is everyone know log n. Inner base is, remember, inner base is starting 1 is this 25. Outer base is power person. Power is this 186. This is the answer. Question number 28 also done. Can you go to question number 29? Very, very interesting one. Right? Question number 29 is going to be very simple. See. I think it is a mixed, but remember everyone, it is a mixed, right? So both the operators are reverse to each other, right? So there may be chance that he will give in one loop only both. There may be chance that he will give everything in one loop only. Everything in one loop only, there may be a chance he will go because they both are reverse to each other. There may be chance of cancellation and all, right? But understand, see this one, very small number first. So inside loop, it should increase finally. Suppose already small inside loop decrementing, I think termination condition never happened. So I think a program will go to infinite loop, means time complexity we cannot find out, means undefined. So definitely because of starting is small, inside should be increment. So let's check. First I power 5. Okay. Next, whatever you have, whole power 7. It became I power 35. Whatever you have, whole square. It became whole square. It became I power 70. It became I power 70. Whatever you have, whole square. It became I power 140. Right? Understand everyone. Whatever you have, whole power 1 by 4. 1 by 4, which is nothing but a power m whole power n, a power mn. So it became I power 140 into 1 by 4. So 4 ones, 4 threes 12. 4, right, 20 there, 4 fives 30, 4 fives 20. Right, 4 threes 12. So 2 there. Right, next one is 4 fives 20, 35. So overall it became, if you observe clearly, overall it became I power 35. Overall, if you observe I power 35, I power 35. Oh, I think, do you believe or not? Starting is small number. Inside loop power, I think definitely it will increase. No problem at all. I think because of always whole power 35, this is also log n is the answer. Inner base is this person, 64. Outer base is this person, 35. So answer is log n, inner 64, outer 35. Exactly. So question number 30 also over. So 29 is over. What is question number 30? Go to the question number 30. Everyone see question number 30. Main I is equal to 10 while I less than or equal to n. I is equal to I plus 7. I is equal to I into 10. I is equal to I power 9. Right? Something like that it is given. So can you see this one? Already started with small. So inside you should increase. Let's see what he is doing. See the answer. I plus 7 first. Increasing. Okay. Next one, whatever you have into 10. That is also okay. Whatever you have, further into 10. Next one, whatever you have, whole power 9. Do you believe or not? Calculating this much big number is going to be little difficult. So instead of taking all, the best thing is small thing neglect. See, comparing plus and multiplication is increasing faster. Comparing 10 and power will increase. So don't think much. It became I power 9 only. So this problem is combination of addition also, multiplication also, power also. But you know very well, power will dominate more. Power will dominate more. Power will dominate more. So take power only. So these two people are only for namesake. These two people are only for namesake. I is equal to I power 9. Right? So even though all three there, final meaning is same only. So I power 9 only. I think power answer is same. Log n. Right? But inner base is this 10. Outer base is 9. We go off log n. That is the answer for this. See, check. Right? Question number 31. See the question number 31. Right? Based on all the basics, based on all our basics, whatever we done till now, one problem. Can you see this one? I think 3 for loops are there. 3 for loops. Everyone observe. 3 for loops are there. See the inner loops. 3 for loops are there. Can you see the inner loop? 3 for loops. Can you see the inner loop? For k is equal to 1, k greater than k power 25, k is equal to 1, k power 27, right? Less than n power 5, k plus plus. Right? And one more, I think, what about I loop? I is always, Right, see this one. If you observe clearly, I is always incrementing by plus 1. K also always incrementing by plus 1. See how it is incrementing, that will decide the time complexity. Wherever power there, please don't go. Wherever power there, please don't go. I is always incrementing by 1. It's not incrementing I power something. I is always incrementing plus 1, plus 1, plus 1. J is always decrementing by 3, by 3, by 3. See, J started with a big number. Always it is divided by 3, 3, 3, divide. So it is divided always by 3. Right? I think if you always divide by 3, you know very well. Log n base 3. It is always going plus 1, plus 1, plus 1. It is actually time complexity n only. But he is doing some small story here. I will check. Observe carefully. Observe carefully. Right? Don't confuse. Within few minutes, you will get the clarity. Right? Right? Listen, everyone. Now, whatever basics we got till now, using all basics, I want to solve one problem. I'm solving. Right? So if you see the J loop is always decrementing divide 3, divide 3, divide 3. So it is a log n base 3. Divide and multiplication is log n will come. If at all power there, root there, log n. Only plus there n. I think actually I loop, actually n, but what is going on you will get to know. What is going on you will get to know. Right? So condition checking time is not checking I less than or equal to n. Is checking I cube is less than or equal to n. What exactly meaning? I will check. See this one. I value initially 1. Okay. 1 cube. First you will check. 1 cube is less than or equal to n or not. If it is true, you will continue further. Next I value becomes 2. You will check 2 cube is less than or equal to n or not. Suppose it is also true. Next I value becomes 3. You will check 3 cube is less than or equal to n or not. If that is also true, you will check. Right? I value became 4. Right? 4 power 3 less than or equal to n or not. Right? Like that you will keep on check. I think if you keep on continue k time, then what happened is k power 3 is equal to n it will become. Lastly, after repeating k time, let us assume k cube is equal to nk. Right? I think if k cube is equal to n, what is the k value? Right? I think then what is the answer? I think k cube is equal, right? Just apply 1 by 3. Whole power 1 by 3. Because I want k value. Right? Both the side do power 1 by 3. Then it became k. K is equal to n power 1 by 3. N power 1 by 3. So remember, right? First loop is n power 1 by 3. Be careful. Don't do anything blindly. So I loop n power 1 by 3. J loop log n base 3. Observe carefully k loop also. Easily will get. See the k loop. K also always plus 1 only. So what is the meaning? First you verified. 1 power 27. K value initially 1. 1 power 27 is less than or equal to n power 5 or not. Yes, true. Assume it is true. In the next round, k value become 2. 2 power 27 is less than or equal to n power 5 or not. If that is also true, next one, 3 power 27 is less than or equal to n power 5 or not. If that is also true, continue. It became, right? So k times assume. K power 27 is equal to, after repeating k time, both became equal. Assume n power 5. So finally I want k value. So k power 27, be careful, whole power 1 by 27. Because I want k 1 by 27 is equal to n power 5 whole power 1 by 27 means it became 5 by 27. Check properly. So finally k become n power 5 by 27. Check properly. So finally k loop is right n power 5 by 27. So let me write n power 5 by 27. And one more, remember, these are inner loops. you have to multiply. These are inner loops. Multiply all three. This one, this one, this one. Multiply all three. Then when you multiply, it became n power 1 by 3. It became log n. It became n power 5 by 27. Right? So whatever it is, just add properly, big O of. Whatever it is there, just add properly, big O of n power 1 by 3 into log n base 3 into n power 5 by 27. Right? So that is the answer for that problem. Right? For this problem, answer is going to be n power 1 by 3 into log n into n power 5 by 27. This is the problem number 31. Right? Let's see the problem number. Right? Problem number. I think is it same problem? Yeah, it is a different problem. Similar way, this also. Right? I think problem number, it is a 32, I think. I will change afterwards number. Please careful. This is a 33. $34. Yeah, totally 34 problems. Yeah, let me do 32. Yeah, 32 I am doing 31 over. See that 32. It is also, remember, it is also inner loops. Inner loops means you have to multiply. Careful everyone, it is also inner loop. Inner loop means you have to multiply. Observe properly, always I incremented by 1. If I incremented by 1, so if it is n means n time. So n power 1 by 3. N place n power 1 by 3 there, whatever there, keep it. Always incrementing plus 1, plus 1, plus 1. So n by 1. If n there, n by 1. But n power 1 by 3 there. Whatever there, right? Whatever there, that one by 1. Next one. Always divide by 3. Log n base 3. Always divide by 3. Log n base 3. Next one. This is, I think if you observe clearly, this is also always plus 1. If always plus 1, n by 1. N is there, n by 1. Right? N power 5 by 27 there, 5 by 27. So multiply all three because of inner loops. Multiply all three. Same thing multiply. So I think this is the same answer. Log n base 3 is a one person. N power 5 by 27 is another person. N power 1 by 3 is another person. Right? Simplify as much as possible. So that is the question number 32. Go to the question number 33. Go to the question number 33. Remember, these are also inner loops. Inner loop means you have to multiply. Inner loops means you have to multiply. Let's see. So if you observe clearly outside, always into 2. Always into 2. If at all always into 2, log n base 2. See, n is there, n. N square there, n square. Log n square base 2. Always into 2, log n base 2. N there, log n base 2. N square there, log n square base 2. Whatever is there, log of it. Right? First loop, I loop is how many times? Always into 2 log n base 2. If n there, n square there, log n square base 2. This can be written as 2 into log n base 2. 2 is a constant, you can ignore, simply log n. Base 2 if you want, you can write. So first loop is log n. Can you see the second loop? I think second loop if you observe, always into 2. Second loop if you observe, always into 2. J is equal to 2 into j. Always into 2. It is also log n base 2. So log n base 2, log n base 2. Inner also log n base 2, outer also. Log n base 2 into log n base 2. Log n base 2 into log n base 2. I think log n base 2 whole square. So which will goes to log n base 2 whole square. Which is going to be log n base 2 whole square. Question number 33, answer is log n base 2 whole square. Right? Observe clearly. Right? Answer is, I think, same. Time complexity, right? So let's check here. Question number 33. 2 inner loops, right? 2 inner loops. First one is outer one is log n base 2, inner one also log n base 2. Right? So finally it is going to be what exactly question is, let me check. So question number 33, one question is given. Time complexity is log n base 2 whole square. Time complexity is log n base 2 whole square because outer one also log n base 2. Check. Inside also log n base 2. Finally log n into log n square. Please check if I done anything wrong. Right? Same answer. So time complexity log n base 2. Log n base 2 whole square. Right? There may be here so many things are there. I think not written clearly. Right? Let me write now. I'm explaining. See this one. Log n base 2 whole square. Time complexity log n base 2 whole square. I will change it. So he is asking x value, but our goal is here only time complexity. Here our goal is only time complexity. So please careful. Time complexity of this program log n base 2 whole square. Right? Value also is written, so you can verify yourself. Our goal is only time complexity. Question number 33, answer is log n whole square. See, somewhere small mistake happened. So written also here. Written also, don't worry. But anyhow, log n base 2 whole square. Time complexity of this problem log n base 2 whole square because outer loop also log n, inner loop also log n. Both are log n base 2 whole square. Question number 33. Question number 33. Please verify yourself. Time complexity log n whole square. Right? Outer one, if you see, log n square base 2, which is nothing but 2 log n, which is nothing but log n. Inner one, if you see, always into 2. Always into 2. So log n base 2. Log n times log n whole square. Time complexity log n. There may be some more values he is asking, x value, something like that. You can find out yourself. That is not the goal. Our goal is here time complexity finding. The purpose of this class is time complexity finding. Right? Fine. Come here. Be careful. Question number 33. Sorry, 34. Question number 34. Observe clearly. Observe clearly. Small change may be there. Observe clearly. See this. So always into 2 log n base 2. If n is there log n base 2, n square there log n square base 2, which became 2 log n. Which became 2 log n base 2. Which is nothing but asymptotically means by neglecting constant log n base 2. So outer loop is log n base 2. Inner loop, if you observe, always plus 2. Always plus 2. N by 2. Right? So n by 2 means n. Inner loops multiply. So time complexity n log n base 2. This is the time complexity. N log n base 2. That is the time complexity. Right? This is. X value, right? You can verify yourself. It is not required because it is a time complexity story only. Time complexity story only. So total, I think I done approximately 35 questions I done. Try to understand. Approximately I done 35 questions, not 1 to 35 questions I done. Approximately 35 questions.